Hello, my dear students. So, have you ever wondered why a shining iron nail turns reddish brown when left outside? Or why a dazzling white flame bursts out when we burn a magnesium ribbon? Well, these aren't just random events, these are chemical reactions. So, my dear students, welcome to our new YouTube channel, Lesson Sport. And today we are kicking off the chapter 1 of your class 10 CBSE chemistry, chemical reactions and equations in the easiest way possible. I have created this channel with one simple mission to take the fear out of science. Whether you are aiming for a perfect 100 out of 100 in your CBSE boards or just want to understand the concept without rote memorization, this is the place for you. So, in today's video, we are going to cover everything from identifying a reaction perfectly and balancing the chemical equations. So, hit that subscribe button, grab your NCRT textbook and notebook, and let's get started. So, we are going to start our first chapter, chemical reactions and equations. Okay. So, you can see two diagrams which I have given over here. So, one is a burning reaction and another is a chemical reaction, right? So, we know a chemical reaction. A chemical reaction means there what will happen, a chemical change will be taking place. So, a new term you have heard, that is a chemical change. So, this is only the first concept that you will be studying in your first chapter. That is the difference between a physical change and a chemical change. So, in order to understand the major difference between these two, I have a very simple example for you. Okay. In your hand, there are two papers. Fine. So, one paper you are going to tear that paper. Another paper you are going to burn that paper. So, whatever the paper which you have torn, you can use a gum, stick it, and you can bring it back to its initial state. Whereas the paper which is being burnt and which has formed ash cannot be restored, right? So, this is only the main difference between a physical change and a chemical change. So, in a physical change, it is reversible in nature. That is, whatever the substance which has been formed, this substance can be converted into its initial state. Okay. But in case of chemical change, what is going to happen? A chemical reaction is going to happen. As a result, a new substance will be formed. Okay. So, that new substance cannot be reversed back to its initial state. That is, we call chemical change as an irreversible reaction, whereas physical change a reversible reaction. Hope this concept is very well clear to you. Okay. Now we are going to move about the topic, what is a chemical reaction. So we have seen a chemical change, we have seen a physical change. Okay, so now we are going to describe or define what is a chemical reaction means. Okay, so I will give you a simple example for the chemical reaction. So here there is an equation. So I am writing this equation, H2 plus O2 gives H2O. Fine. So this chemical reaction represents the formation of water. Okay. So in order for a chemical reaction to take place, we have to take certain initial substance, right? So this initial substance under certain conditions will be undergoing a chemical reaction. So, the substance which is taking part in a chemical reaction. So, here hydrogen and oxygen are the substances which are taking part in a chemical reaction, right? So, such substances are called as reactants. Okay, reactants. So what will happen? These chemical substances which are called as reactants will be participating in a chemical reaction. Okay, as a result of this chemical reaction, what is formed? A new substance is formed, right, which is totally different from our reactant. A new substance is formed which is totally different from our reactant. So this new substance which is being formed is known as product. So it is called as product. So simply, if someone asks you what is a chemical reaction, you can define it like this. That is, chemical reaction is a process in which the reactants are transformed into product. So you should be aware what is reactants and what are product. So reactants are substances which will be taking part in a chemical reaction, whereas products are substances which are formed as a result of chemical reaction. So this is our general representation of a chemical reaction. That is, reactants will be combining and it will be giving what? Products. Hope this is clear to you. So we will move to the next slide. Okay. So, three examples are given in your textbook, okay, based on the chemical reactions. So, first example which is described in your textbook is burning of magnesium ribbon. Okay, so this is the pictorial representation of the burning of magnesium ribbon. So you can see a white dazzling flame, right? So whenever a magnesium ribbon is burned, it will be producing a white dazzling flame. Okay, so this is the first observation that you will be seeing. When a magnesium ribbon is burned, it will be giving a white dazzling flame. Okay. After that, when this magnesium ribbon has burned completely, what will happen is we can see the formation of a white colored powder. Okay, we can see the formation of a white colored powder. Okay, so what is happening here is when we are burning magnesium, magnesium will be reacting with oxygen, or magnesium will be combining with oxygen, and we will be getting a new product which is called as magnesium oxide. So the chemical equation for this reaction is represented over here. That is Mg. Mg stands for magnesium. Magnesium will be reacting with oxygen O2 and it is forming what? Magnesium oxide MgO. So I have already mentioned a white colored powder is formed, right? So this white colored powder is nothing but the formation of what? Magnesium oxide. So this is the way the questions will be asked for your board exam. Like I will give you one example. They will ask like this. A compound X will be burning with a white dazzling flame and it will be producing a white colored compound B. What is that compound A? What is that compound B? This is how the questions will be asked. Okay. So magnesium burns with a white dazzling flame, and because of this reaction, what is formed? A white colored powder is formed. That white colored powder is nothing but magnesium oxide. Hope this reaction is very well clear to you, and it is also one of the important reaction for your exam. Okay, let's move to the next slide. Reaction of zinc with hydrochloric acid. Okay, so reaction of zinc with hydrochloric acid. So you can see the diagram over here, right? So when we are taking hydrochloric acid in a test tube and adding zinc granules. So as soon as we add zinc granules, as you can see over here, there is a formation of small bubbles. So in chemistry, in every other chapters, you can see so many reactions that involves the formation of bubbles. So whenever there is a formation of bubbles, we have to remember that there is a formation of certain gases which is taking place. Here also, whenever zinc is added to hydrochloric acid, a gas is formed. Okay, this is very important. They will ask which gas is formed. So the gas which is formed here is hydrogen gas. Okay, so zinc will be combining with our HCl and it will be forming what? Zinc chloride. A product is formed, that is zinc chloride. Along with that, what is liberated? Hydrogen gas will be liberated. Okay, clear with this equation? So zinc will be reacting with hydrochloric acid and it will be producing what? Zinc chloride and hydrogen gas. Okay, there is a formation of bubbles over here. The formation of bubbles indicates the presence of certain gas. Here the gas which is formed is hydrogen gas. Okay, so we have told this is a hydrogen gas. Now we are going to see a test where we confirm the gas which is formed here is hydrogen or not. Okay, so let's see what is that test. So this is the confirmatory test for hydrogen. So this confirmatory test for hydrogen, again in later on you will be studying confirmatory test for oxygen, carbon dioxide and all. So this confirmatory test is very important from exam point of view. Okay, so confirmatory test for hydrogen. So if we will be collecting the hydrogen gas, okay. So after that what we will do is we will be placing a burning candle or we will be placing a burning matchstick near to the mouth of this hydrogen gas. So what will happen here is if this gas is hydrogen, hydrogen gas will always burns with a pop sound. Very important, hydrogen gas will always burns with a pop sound. So this is the confirmatory test for hydrogen. So whenever you are bringing a burning candle or a matchstick near to the hydrogen gas will always burns with a pop sound. Okay, hope this confirmation test is also clear to you, which is very important from the exam point of view. So this is about the second reaction, that is reaction of zinc with HCl. So we have studied the reaction of magnesium and oxygen or burning of magnesium we have seen, and the reaction of zinc with HCl. Now we are going to see the reaction of lead nitrate and potassium iodide. Okay, lead nitrate and potassium iodide. As you can see in this figure, this is lead nitrate solution and this is potassium iodide solution. So both of these solutions are colorless. Okay, whether it is potassium iodide or lead nitrate, both of these solutions are colorless. Now what we are going to do is we are going to mix these two solutions together in equal amount. So this is what we are going to get when we are mixing these two solutions. So when we have mixed lead nitrate and potassium iodide together, what we can see the formation of a yellow colored substance, right? Okay, so this yellow colored substance, what is the speciality is this yellow colored substance is insoluble in water. Got it? It will not be soluble in water. Once we are keeping this test tube undisturbed for some time, what we can see is this substance, that is yellow colored substance, will be getting settled down. Okay, so such a substance is known as precipitate. Okay, you will be studying this further. Precipitate. Okay, so here also what has formed is lead nitrate. Lead nitrate formula is PbNO3 and it has reacted with what? Potassium iodide. Potassium iodide formula is Ki. So when it has combined together, I told there is a formation of yellow colored substance, right? So that yellow colored substance is nothing but it is due to the formation of what? Lead iodide. Okay, when these two combine together, a new product is formed, that is lead iodide. So this lead iodide is having a yellow color. Got it? So that is why we can see a yellow color or we can see the formation of a yellow colored precipitate. Another product which is formed is KNO3. Okay, that is potassium nitrate is also formed. So this is the third reaction, chemical reaction that you have seen. Now if we take these three reactions, whatever the reactions that we have mentioned just now, Okay, so second reaction if we take, that is reaction of zinc with hydrochloric acid, we can see that there is a formation of gas, right? So that there is a formation of gas in the third reaction that we have mentioned here, that is reaction of lead nitrate with potassium iodide. What we can see the formation of a yellow colored substance which is called as precipitate. So the speciality of the precipitate is precipitates are insoluble in water. Got it? So yellow colored precipitate, that is there is a change in color of the solution has taken place. In the second case there will be an evolution of gas, right? So whenever a chemical reaction is taking place, some changes will be happening. Okay, observable changes will be happening whenever a chemical reaction is taking place. So now we are going to see what are the changes which will be taking place in during a chemical reaction. Okay, so in either of any of these changes will be taking place. So we are going to see what are those changes. Got it? So indicators of a chemical reaction. Indicators of a chemical reaction means how we can indicate whether a chemical reaction has taken place or not. So first is whenever a chemical reaction has taken place, okay, there will be either change in the state. Okay, change in the state, here you can see the example, that is reaction of hydrogen and oxygen. So you can see hydrogen is a gas, right? Oxygen is also a gas, but you just see the product formed, that is water, right? Water which is in the liquid state. So here change in state has taken place, that is gas has converted into what? Liquid. Same way solid will be getting converted into liquid, or solid will be getting converted into gas also. So whenever a chemical reaction takes place, there is a chance that change in state can takes place. Clear? Now next is change in color. Change in color, the example has already been mentioned before, right? That is whenever the colorless solution of potassium iodide as well as lead nitrate is mixed together, we are getting a yellow color. That is there is a change in color, right? Okay, that is the second case. Now third case also discussed, that is there will be evolution of some gases like hydrogen gas, oxygen gas, or any gases can be evolved whenever a chemical reaction takes place. There is a chance that there will be an evolution of gas. Now there will be a change in temperature also. Okay, so these are all examples we will be studying. Change in temperature in the sense either whenever reaction has taken place, the temperature of that reaction can increase gradually, or the temperature of that reaction can decreases gradually. So there will be a change in temperature. Now last is the formation of precipitate. That also we have discussed. So this formation of precipitate and change in color can be categorized together. Okay. So these are the indicators of a chemical reaction. So whenever a chemical reaction is formed, there will be change in state, change in color, evolution of gas, or change in temperature. So hope the concept of chemical reaction is very well clear to you. So chemical reaction means reactants will be getting converted to product. So reactants means substance taking part in a chemical reaction, and the new substance which is formed as a chemical reaction is known as product. We have seen three different types of chemical reactions and the indicators for a chemical reaction. Okay, now we are going to move a very important concept in this chapter, that is balancing a chemical reaction. Okay, before that we have to study certain terms, that is what is this word equation, what is this chemical equation, and all. Okay, so if you are thorough with the concept of reactants and products only, you can move to where balancing a chemical equation. So first we can see how we will represent a chemical reaction. So I told like magnesium will be reacting with oxygen to form magnesium oxide. That is a statement, right? Okay, so with this statement we are going to convert it in the form of an equation. Got it? So first is Either we can use the word equation, okay, but we will not be following the word equation. So word equation means what? First, what we will do is we will be writing the names of the reactants that we have taken. So burning of magnesium ribbon, here the reactants are what? Magnesium and oxygen. So if two or more than two reactants are there, so what we have to do, we have to add, that is use the addition symbol, okay, magnesium plus oxygen. Got it? After that, we have to use a arrow, that is forward arrow we have to use. So in chemistry, this arrow means whenever you are seeing this arrow along with the chemical equation, you have to read it as gives, that is magnesium and oxygen will be reacting and it will be giving something, right? So gives we will read, okay. So magnesium and oxygen, that are our reactants. After reactants, what we have to do, we have to write, when all the reactants are done, you have to use a forward arrow, okay. Now next, after the forward arrow only, you can represent the product. So here the product which is formed is magnesium oxide. Got it? So this is how you will be writing a word equation. That is, you will be writing the whole name of the reactants and products that you are going to take. Now next is, this word equation is lengthy, right? So you can simplify it more. Fine, you can simplify it more. So the simplified version of this word equation is known as chemical equation. So this one is called the chemical equation. So chemical equation, what we will do is, the chemical equation is a symbolic representation of a chemical reaction. So chemical reaction, instead of representing in the form of words, what we will do is, we will be representing it in the form of symbols. So here the symbols that we are going to use is the symbols of the elements. Hope the symbols of the elements you have studied in your earlier classes, right? So with these symbols, instead of writing their names, we will be using these symbols and write the chemical equation. Got it? That is called the chemical equation. That is, it is the symbolic representation of a chemical reaction. Clear? So here you can see magnesium. The formula of magnesium is what? Mg. Oxygen. Oxygen is a diatomic molecule. You have studied, right? So O2 we will write. You should not go for writing O, okay? You have to write what? O2. Okay, so O2 will be giving what? Magnesium oxide, MgO. You are also familiar with writing the chemical formula, which we have studied in your earlier class, right? So this is how we will be representing what? Chemical equation. So these are the components of a chemical equation. So arrow mark will be there. Left hand side of the arrow mark, here you will be representing the reactants. After that, arrow should be there. And on the right hand side of the arrow, you have to write what? Products. Okay. So this is how you will be writing a chemical formula and chemical equation. Hope this is clear to you. Let's move on to the next slide. Now, next is the difference between balanced equation and unbalanced equation. Okay, so before balancing the equation, you should be familiar what is this balanced equation and what is this unbalanced equation, right? So I am going to tell you the basic difference between the balanced equation as well as unbalanced equation. So you can see here two diagrams I have given. So this is a very simple way to understand what is balanced equation and unbalanced equation. So you just count the number of hydrogen atom and oxygen atom and both the sides of your equation. That is, in the reactant side you have to, and also in the product side. So first equation we can count. So here you just see 2 hydrogen is there, right? So you can write 2 over here. Okay, here you can see what? 2 oxygen atoms. So 2 oxygen atom is over here. Now a product is formed, right? So in the product, you just count the hydrogen atom. 1 hydrogen atom is over here, another hydrogen atom is over here. So 2 hydrogen atom are there in our product, but oxygen atom you just see only 1 oxygen atom is there, right? 1 oxygen atom. Fine. Now see the second diagram. Here you just count how many hydrogen is there. 2 plus 2 you will be getting 4. Here how many oxygen atom is there? 2. Okay. Now here you just count 1, 2, 3, 4. Right. So 4 hydrogen atom is there. Count oxygen atom. 1, 2 oxygen atom is also there. So from this only you got the difference, right? So in the first equation, what you can see, the number of hydrogen and oxygen in the reactant side and in the product side are not equal. But in the second case, you just see number of hydrogen and oxygen in the reactant side as well as in the product side are equal, right? So this first represents what? Unbalanced chemical equation. Got it? So unbalanced chemical equation means these are the chemical equation in which number of atoms on the reactant side as well as on the product side are not equal. Got it? So an unbalanced equation shows reacting chemicals but has unequal atom counts. Okay, so number of atoms on the reactant side and the product side are not equal. Okay, so this unbalanced equation are also called as what? Skeletal equation, which is very important. So in many of the question paper, they have asked a question like this. What is skeletal equation? Okay, so unbalanced chemical equations are called as skeletal equations. Fine. Now in the second case, you can see what? Number of hydrogen atom and oxygen atom in the reactant side as well as in the product side are equal, right? So such equations are called balanced chemical equation. Got it? So balanced chemical equation has equal number of atoms on the reactant side as well as on the product side. Got it? So one thing, like you will be given an unbalanced equation where the number of atoms on the reactant side and product side will not be equal. So you are going to make the number of atoms equal. That is, you are going to study how you will be doing balancing a chemical equation. So before studying the balancing a chemical equation, what is the need of this balancing? Okay, the need of this balancing is based on a law. Okay, it is based on a law. We are going to see what is that law is about. So balancing of chemical equation is based on a law which is known as law of conservation of mass. Okay, it is based on a law which is called as law of conservation of mass. Hope this law is very well clear to all of my students, right? So what this law states, that is, mass can neither be created nor be destroyed in a chemical reaction, right? So here you can see whatever the mass of the reactants that you are taking on the reactant side, it should be equal on the product side, right? So in order to make the mass equal, what we can do, we can make the number of atoms equal on both sides, right? So for example, like if you have 2 hydrogen atom in your reactant side and 1 hydrogen atom in the product side. Okay, so 2 hydrogen atom, its mass will be 2, 1 hydrogen atom, its mass will be 1. So you have to make this 1 2 equal, right? So what you can do, you can add one more hydrogen atom here. So 1 plus 1 means you will be getting 2, right? Okay, so balancing a chemical equation is based on what? Law of conservation of mass. And this, what this law states is, mass can neither be created nor be destroyed in a chemical reaction. So in order to balance the chemical equation, what we have to do, we have to make the number of atoms equal on the reactant side as well as on the product side. Got it? So now we are going to see how we will be doing or how we will be making this equal. Okay. So I have some chemical equations for you. Okay. So 2 chemical equations, I will be doing it for you and I will be making you clear. Fine. After that, these 2 equations, you have to work it out and just tell me in the comment box whether you are getting the answer or not. Okay. So first equation, KBr plus BaI2 gives Ki plus BaBr2. Okay, so whenever an equation is given to you in your textbook, you are given a column, you have to, no need of doing like that. A simple trick I will tell you. Okay, so whenever an equation is given to you, you just analyze that equation first. After that, start counting from the first. So KBr, that is we have potassium, right? So in the reactant side, we have one potassium. Now you just see in the product side also you have one potassium. So potassium is bad, that is it equal number, right? Now bromine you just see in the reactant side, bromine we have one bromine. But in the product side, what you can see, we have Br2. Br2 means bromine, we have two bromine atom, right? So two bromine. Okay. Now you just see Ba means barium. Barium here you can see 1. Okay. In the product side also barium it is 1. Now I2, iodine, you have 2 iodine in the reactant side. But you just see here you have only 1 iodine in the product side. So you got an idea, right? So or else what you can do is you can just make a table over here. So in the first table you can write reactant, in the second table you can write the product. Okay, so you just see what are the reactant. In the reactant case, potassium is there. How many potassium is there? 1, right? In the product case, how many potassium is there? Potassium is also 1. Okay, now next is bromine. Okay, bromine, how many bromine is there? In the reactant side, 1. What about the product side? In product side you will be having 2 reactants, sorry, 2 bromine. Now barium you have only 1 barium in the reactant side. Product side also if you are taking, you have only 1 barium. Now next is iodine. You have 2 iodine in the reactant side, and iodine you have 1 iodine in the reactant side. So you got an idea. You can make a table like this. Okay, you got an idea how many reactants and products are there. Okay, so potassium no need of balancing because it is already balanced, right? Now second you just see Br. Okay, bromine you have, right? So bromine only 1 bromine in the reactant side, whereas 2 bromine in the product side. So it is not equal. So what you have to do, you have to make lesser number, you have to take, that is this 1 bromine you have to make 2. Okay, so 1, how you will make 2? 1 multiplied by 2 will give you 2, right? So same multiplication you have to follow here. So here you have to add 2 to this bromine, right? Okay, or you have to multiply 2 to this bromine. So remember, when you are multiplying any number in order to balance that equation, you should not go for writing at the below. This is very big mistake. Okay, so many of the students will be doing the same. So now you will be thinking where you will be putting this, right? So here where you have to put is always when you are balancing an equation, if you want to put a new number, you have to put at the front. Okay, so what you will get? 2 kbr. Got it? You will be getting 2 kbr. Now you just remember one thing. So we have put what? 2 kbr, right? So this 2 is not for bromine. This 2 is common for whom? Both potassium and bromine. Got it? So this 2 is common for both potassium and bromine. So this 2 is common means here you can see 2K. 2K means potassium. 1 potassium has changed to 2, right? Bromine also changed to 2. Now you just see the product side here only one potassium is here, right? So potassium now become unbalanced. So what we have to do? We have to balance this potassium, right? So for that, what we have to do is we will be putting 2 at the front. So what you will get? 2 kBr plus BaI2 gives 2 Ki plus Br2. So now you just, after that you just count whether it is equal or not, balanced or unbalanced. So 2 is common, so 2K, here also 2K. Potassium is balanced. 2Br here, here also Br2. Bromine is balanced. Ba, 1 Ba here, here also 1 Ba. Ba is also balanced. Now I2, 2 iodine is here. Remember, we have put 2 in front of potassium. So this 2 is common for both potassium and iodine, right? So iodine also 2. So this is a balanced chemical equation. Got it? So after adding each number, you have to check it whether it is balanced or not. Okay, you have to count it and you have to confirm whether equal number is there in both sides. Don't go just by putting 1, 2, don't stop it there. You have to count it once. You have, if it is not balanced, again you have to go for balance. Sometimes within a single step you will get, but sometimes you have to do 2, 3, 4 steps to get a balanced equation. Got it? So that you have to keep in mind. Now we will move to the second equation. ZnCO3 gives ZnO plus CO2. Okay, so you can see here is Zn, zinc. Here one zinc is there. Here also one zinc is there. So zinc is balanced, right? Now you just see carbon. One carbon here, one more carbon here. Carbon is also balanced. Now you just see O3. O3 means 3 oxygen is there. Here you can see 1 oxygen here, plus you can see 2 oxygen here. So 1 plus 2, 3. So you, in this equation, all the atoms, number of all the atoms on the reactant side and the product side are equal, right? So we can call it as a balanced equation. So sometimes in the question they will give you a series of equation and they will ask you to identify which is a balanced equation, which is an unbalanced equation. If it is unbalanced, you have to balance that equation. Got it? Now let's do this one, third one. Okay, here you can see H2, 2 hydrogen is there, but here HCl, only 1 hydrogen. So 1 hydrogen, you have to make it 2. So where you have to put? You have to put 2 at the start. So 2 HCl. Now this 2 is common for hydrogen as well as chlorine. So 2 hydrogen is there, chlorine also become 2. Here also 2 chlorine. Got it? So this equation is balanced. Just try to do the last one and drop your answer in the comment box. Okay. So hope whatever the topics that we have discussed today is very well clear for you. Okay, and that's wrap up our complete guide to balancing a chemical equation. So we have covered the basics as well as some questions, and in this video I hope this video has made chemical reactions and chemical equations, balancing a chemical equations and all, a little easier for you. So please hit that like button, share it with your class 10 friends, and don't forget to subscribe for the chemistry's chapter 1's next topic, that is types of chemical reactions and the activities that is being discussed in the textbook. So thank you so much for watching. Study hard and I will see you in the next video. Thank you all.